Are those the same number of zeros there? I'm going to ask Andrew, how would I go about taking the name array matrix and the X matrix and multiplying them together to produce a third matrix?
Rows and columns, matrix multiplication.
So I fill up these two matrices that I have defined, and I have a third one that I have defined, and I have to go through every single row and every single column of each one. That becomes a problem, doesn't it? Do you suppose that we ever have a problem that size?
Sometimes.
Yeah, we do. And so we just simply flat run out of memory in those contexts. Okay? So the matrix multiplication idea is something we call a sparse matrix. Andrew, what's a sparse matrix? I'm picking on our math major here, sorry.
Sparse matrix is a matrix with majority zeros.
A lot of zeros in there, a lot of empty spaces. So we could, now if every single one of these cells needed to be filled, had something in it, and then we did our matrix multiplication, yeah, we'd have to have, it would make sense to do this. We'd just have to get a bigger machine or break it up and do some sub-matrices and generate our result that way. However, most of the time these matrices are what we call sparse, where there's lots of cells that are zero, lots of cells that are unneeded. And so if we implemented these matrices by doing what we call a ragged edged array, okay, then I only need the elements that are in each row. And maybe some rows are empty. Okay, and I can develop a notational convention that would let me do step from one row to another, skipping over those rows that are empty. Okay, that's kind of an extreme example, but I'm trying to make the point that the two-dimensional array business or three-dimensional array business is a huge waste of space and a huge waste of time. Okay? Therefore, we spend a whole lot of time dealing with other data structures that are more efficient. Here's one of them. Two-dimensional array is the first data structure that we see. This next one, ragged edged arrays, is another data structure. You understand that this char z 10 by 20 character array is actually the first dimension, z sub 0. What's in z sub 0? It's actually a pointer to, it's the address of that first row, isn't it? Okay. Z sub 1 is actually a pointer to the second row. Okay, so already this notation is an array of pointers to arrays. Is that clear? Underneath the hood, that's how it's actually implemented. It's the difference here in this case versus this case is that in this one we allocate only the amount of space we actually need. In this one we allocate excess. So everything is nice and uniform. Got the point? So we're not talking about anything new, really. We're just looking below the surface and saying, what really is going on in this kind of a declaration? Okay? Well, char star names sub 6, and we initialize each one to these three strings, exactly only the exact amount of space we need for each one. And that's cool for implementation for initialization kind of things, ranks and suits, ace, deuce, tray, and so on. We can initialize things nice and cleverly that way. But when we we start to look at, I don't want to do an initialization, I want to actually put some values in there myself. Then I need some way of allocating an array that points to character strings, and the character strings are dynamically allocated. So here we have what we call dynamic 2D arrays. This is a situation in which names is actually a two-dimensional array, isn't it? Isn't names a two-dimensional array? There's nothing in it, and we created initially the variable, initializing it to 0, so it's not pointing at anything. So it's up to us to allocate just the right amount. Now in this case, numNames says how many. It's an integer, and it says how many. How long is my array going to be? And we allocate exactly that amount of space. What is the data type of this new array? What are we actually allocating? What are we actually allocating?
Addresses.
We're actually allocating an array of addresses, but is it just any old addresses? No, we are being more specific on the data type and requiring that array of addresses be of addresses of type character. So the key here is we're allocating char star, an array of char star. The start address of that is here. It's placed in names. So names points to an array of pointers, and therefore it's needed that we do it's necessary that we do char star star. Questions there? No? Okay. To assign the address of dynamic array of characters to an element in the pointer array, we need first to allocate the space. So in this case, we're using buffer, and we're going to reuse buffer over and over again. It's just a temporary place to store a character string that we type in, enter a name. Now, new char string length of buffer, how many characters do we enter? Plus 1. That's how many I want to bring in, and I'll assign that for the moment to str. str, what is the data type of str? What must it be? Kelvin? A pointer to what? Pointer to character. Okay? So str is char star. It's a data type. Only one star there. And then we copy. It's necessary to copy. I can't do this, can I? Can't say str equals buffer. Can I say that? Well, I can. Syntactically, it's legal. What am I doing?
Shallow copy.
Shallow copy, copying the address of one to the other. Just the address. So str points back to the original buffer, whatever happens to be in it. Which is not what I want. What I want to do is actually place the values that were in buffer into this thing that we just allocated. Now this assignment does what? What is I in this case? I is 0, and so into the 0th cell of the names array, and the names array is an array of character pointers, right? Can you decipher for me exactly what this says? And it's useful, and at some point I will have you do it in pointer notation instead of array notation. But what does that actually say?
Dereference the address names with offset I.
Dereference names. Okay, so go to names. That's an address, isn't it? It's a spot here. And then Offset from that, what? I number of spaces, I number of addresses, because names is an address array, or an array of addresses. And so names is sitting here pointing to something. Go there, come down I amount, and you'll find a spot, a place that'll hold an address. The right-hand side here is str. The R value of str is an address of a character string. Clear? Questions with that? Okay. Moving on. Now we get into the notion of dynamic. It isn't always feasible to